All right, you guys, so in this case, we're going to go ahead and talk about lesson 7.3, which is focusing on reflection. In this case, just reflection is a transformation that acts like a mirror. So it's basically reflecting one point or a certain shape onto a certain line. So we're going to go ahead and see a few examples here. So starting off with this first one here, guys, it says plot the image of point Q under a reflection across the x-axis. In this case, point Q is our point here, the one that's in green. It's right there. That's our point. And they want us to reflect it upon or across the x-axis. X-axis is the line that runs horizontally in this case. Now, how reflection works, once again, if I were to fold, for example, this graph in half using my half being, in this case, x-axis, there should actually be another point somewhere over here. Now, how we determine that is you actually want to go ahead and count the distance from that point to our line of reflection. So in this case, if we count that out, that's actually 4. So my new point should actually be 4 spaces away from the x-axis, our line of reflection. So in this case here, where we have -4, would be our Q prime. That would be Q prime. Okay. So let's go ahead and move on to this next one. In this one, it says plot the image of triangle ABC under the reflection across the x-axis. So once again, now we're focused on a shape, and they want us to reflect it across the x-axis. Once again, the x-axis runs horizontally. Now, in this case, once again, we're counting the distance from each point or of each point from the x-axis. So for example, A in this case is actually on my x-axis. So my new point A prime is at the same location as A because it's exactly on the line. Now, in this case, let's move on to B, and B is 1, 2, 3, 4, and 5 spaces away, which means that it should now be 5 spaces below my x-axis, which is here, and that is B prime. All right, now let's go ahead and try C. 1, 2, 3, 4, and then 1, 2, 3, 4. And in this case, guys, it is going to be directly down just because our line of reflection in this case is horizontally. We're going to be moving downward. If it'd be vertically, then we'd either be moving left or right here. So let me actually just go ahead and connect these here. And that would be our new shape. New shape there. New shape. All right, next one. In this case, talks about quadrilateral ABCD. And it's reflected across this line. Now, this isn't an axis. It's just a random line we have here. And we want to go ahead and reflect our shape onto this line. Now, in this case, guys, once again, C is actually going to be staying there because it is on our line. Now, if we take a look at D in this case, D is actually 1 space away from my line, which means it should also be, the new point should also be 1 space away. So that's that one. Now let's go ahead and move on to A. A is 2 spaces away, so it's also 1 and 2 spaces away, which means A prime should be here. And let me just move this one. Let's do that again. I just want to move the D away from there. Down here. All right, now moving on to B, it's 1, 2, 3, then 1, 2, 3. So B prime should be there. So let's go ahead and connect that. And that would be our new shape reflected in this case, our new shape reflected. Now, that's about doing a reflection. Now, let's go ahead and focus on identifying a reflection. So in this case, it says draw a line of reflection that reflects triangle ABC onto triangle A prime, B prime, C prime. Now, in this case, guys, notice here how ABC is actually our original shape. And then the reflection in this case is A prime, B prime, C prime. So in this case, actually notice how it's actually going this direction where I'm lining up. I could line up B, I could line up C and D here, or A actually. So I'm actually just going to go ahead and use one of these points. I'm actually going to use C, and I want to see the distance from C to C prime. So that's 1, 2, 3, 4, 5, 6. Now our line of reflection in this case, guys, is actually half way of both points. Both points here. So in this case, half of 6 is 3. So if I count 3 spaces from either C or C prime, I should find my line of reflection. And in this case, it's going to be here. So in this case, I'll be drawing a line vertically, or horizontally, I mean, on 1. So once again, if I were to fold let's say this were a paper and I fold it through here, these both should be on top of each other. Now, in this case, guys, how I identify this line is that this line is actually going through our y-axis. So because it's going through the y-axis, we're going to go ahead and write y equals. And we're going to go ahead and write what it equals. In this case, it passes through the point 1. So my answer here would be y equals 1. And once again, the direction you could see is if it's, in this case, if I want to say if you're going vertically from one shape to the other, then your line should be horizontal. So once again, if your line here, or if you see that the points are going vertically down from each other, your line will be horizontal here. Now, let's go ahead and take a look at this one here. And this one, we have quadrilateral ABCD onto quadrilateral A prime, C prime, D prime, A prime, B prime, C prime, D prime. That's a tongue twister there. So in this case, we want to go ahead and do a line of reflection once again. And I could actually choose any point here, guys. So I could choose B, and in this case, distance is 1, 2, 3, 4, 6, 7, 8. Half of 8 is 4. So let's go ahead and count 1, 2, 3, 4. That means I should have my line going through here. Now, I could actually just continue counting on all the other ones, and I will actually be having the same distance on both sides. So let's say if I do D, it's 1, 2, 3, 4, 5 spaces away, and then it's 1, 2, 3, 4, 5 as well on the other point. Now, in this case, guys, my points here are going horizontal, which in this case, the line of reflection should be the opposite, which is vertical. So then in this case, my line here should be X because it's going through the X-axis, and it's X equals 2 because it crosses at X equals 2. So that would be my answer.